Barbeau, who's a principal mobile software architect for research and development here at the Center for Urban Transportation Research. Sean has served as the principal investigator for multiple research projects investigating intelligent software systems for mobile phones. He has over 40 peer-reviewed papers and conference presentations and was a member of an international expert group with developed a Java-based software standard for location-aware mobile phones. Sean has 7 patented inventions with another 8 pending in the area of location-aware technology. He holds a BS, MS in computer science from USF, as well as a PhD in computer science and engineering from the University of South Florida. With that, let me turn it over to Sean. Sean?
Thanks, Phil. So today we're going to talk about open transit data from a developer's perspective. As Phil mentioned, my background's in computer science, and we've been a part of several projects here at CUTR that have focused on mobile applications in the realm of public transportation. So we've learned a lot as part of those projects of what works and what doesn't work and what's typically expected from a mobile application developer's perspective when you're dealing with something like open data for public transportation. So in today's presentation, I will cover the following topics. So first, we're going to talk about why open data. Why is it important? Second, we're going to talk about the anatomy of transit data sharing. So this is the general structure of the different types of information that a developer would expect to have access to as part of developing a mobile application. Finally, we're going to talk about some tips of being developer friendly. So first, why open data? Typically, open data is considered transit data that's shared with the general public. The mediums to share this information is typically websites, FTP sites, or web services. These data really shouldn't be protected behind logins that require a username and password, because this makes it really difficult for developers to update their application when new information is released. It's very difficult to automate it if it's protected via username and password. There are other ways to secure access to data and to an API using things such as an API key. So that's really the generally accepted method, and it's considered open data if it's openly available on a website and via a method that's really easy for application developers to update their application. And that open data should also be updated regularly by the agency with any changes in schedule, routes, or stops. So if there's a schedule in service, it should be immediately reflected in that same data. Because if it's not, then the applications that are consuming that data are going to be showing information about routes or stops or schedules that don't actually exist in real life. One thing that's important to distinguish when we're talking about the concept of open data and other things that are open in the realm of technology, there's 3 common terms which tend to be interchanged by some people that aren't really familiar with them, and it's important to distinguish that these are all unique terms that mean different things to developers. So open architectures first. The term open architecture focuses on standards within an agency's own software or hardware system. So in the diagram that we have in the lower left-hand corner, we have a transit agency that has things like a transit vehicle, a scheduling software system, an AVL system. So an open architecture allows an agency to plug in different components within their own infrastructure and relying on different formats to do that are open and not proprietary to a particular vendor. We also encounter open architectures when we're talking about government 2.0 or open government systems that interface with other government systems. But these open architectures typically don't include or don't necessarily include access by external developers. So you can have an open architecture within an agency, but if that is not open to the general public to have access to, it's not considered open in terms of open data. The second open term is open source. Open source means that the software source code is actually available to the general public to use, and Common open source projects in the area of public transportation include Open Trip Planner and One Bus Away. And that differs from closed source applications, which are proprietary to specific vendors. But this refers to the software itself, not to data that describes transit service. So finally, what we're going to be talking about today, and what people, people typically refer to the term open data, what they mean is the sharing of the data with the external public parties. So this is John Doe, who's a member of the general public, can somehow access the data from the transit agency to produce an application, and there's not necessarily any pre-existing business relationship or particular access credentials between the third-party developer and the transit agency. It's open data that the agency shares, typically with a set of terms of service, which we'll talk about a little bit later. But the important part is that that data is just open to the general public to use. It's not closed. So this is what we'll be talking about in today's presentation, is open data. So why is open data important? Open data allows the public to contribute services that are either cost or time prohibitive for the public sector to produce. So one area that's seen a lot of activity in the public transportation industry is mobile apps for public transit. So there's a lot of different mobile application platforms when you look at all the different varieties of vendors, manufacturers of devices, things from the iPhone to Android, Windows Phone, BlackBerry, Nokia. There's a lot of different platforms out there, and each application that's developed specifically for a native platform isn't compatible with another native platform. So there's a lot of effort that needs to go into creating native mobile apps for all these mobile platforms. And typically a transit agency just doesn't have the resources in-house to do that. So by sharing your data openly, it allows the public to fill these gaps. So if, for example, there's an Android software developer that uses public transportation and wants to be able to create a service that shares the real-time arrival information for an agency with other writers, he's able to do that, where it would be very expensive for the agency to contract for a service like that. It is important to note that the public won't necessarily fulfill all the needs of the agency, but it's a good way to, open data is a good way to get started and to allow the third-party developers to tackle some areas that they're familiar with and that are useful to the general public. And the second reason here is that vendors can just be unpredictable. So in the past, some agencies in the United States have chosen to share their data only with a particular vendor. So for example, Google for Google Transit. But because of certain business decisions, that service may or may not exist tomorrow. And a good example of that is when Apple dropped Google Maps from its latest iPhone and iOS operating system, iOS 6. When that happened, because Google Transit was part of the Google Maps application, iPhone users lost public transit directions in their native mapping app for about 2.5 months. So they just didn't have an option to access public transportation directions. And Apple openly stated that they didn't intend to create a transit directions application themselves, and they were relying on third-party apps to fill that gap. But the key there is that there's only third-party apps for public transportation will only exist if that transit agency in a particular city has chosen to share their data with the general public. So by sharing your data openly, you just diversify your dissemination channels and essentially reduce the risk that your dissemination channel is going to be cut off by a random decision by or seemingly random decision by one particular vendor. And secondly, so why is open data important to developers? Typically, developers want to create innovative apps that meet a particular need. So they may use public transportation daily and see a way that information distributed via a mobile app could make transit riders' experience much more pleasant. Some of these apps are monetized, some are not, so money is an incentive for some developers. Others just do it for a variety of reasons, from having something to add to their portfolio to just genuinely having something that's useful for them and others. And what we've seen in the past is that if transit agencies don't provide open data, developers will often improvise and get really creative as to how to get data from the agency in an unauthorized manner to create applications. And one manner of doing that is scraping the web, scraping transit agencies' websites, which means that the schedules that are printed up on a website for anyone to access via internet browser, they're really meant to be human readable, but you can create software to access that information. But that software is typically fragile, it's prone to breaking, which means that applications that are based on this screen scraping, website scraping, can be unpredictable. They can be up one day and down the next. So at the end of the day, that experience really isn't beneficial to writers, and it isn't beneficial to the agency either. So it's really in the agency's best interest to create an official open data feed that gives them some method of control, and they can have terms of use associated with that, and also provides the data in a good format that developers can use and provides a stable service. So next I'm going to talk about the anatomy of transit data sharing. So what do the different types of transit data look like? There's really two types of open transit data. The first is static. So these are transit schedules, routes, and stops. This information typically changes only a few times per year. The second type of open transit data is real-time information. This can include things like estimated arrival times, vehicle positions, and service alerts. This information can change every few seconds. So if you have a bus that's delayed in traffic, for example, the estimated arrival time can change very quickly from, say, 5 minutes to 6 or 7 minutes, just based on the traffic that's being encountered. And then within those two types of open data, we have two magnitudes of open data. So the first magnitude is what we refer to as a fire hose magnitude. So this is really the largest magnitude. It's a dump of the complete state of the transit system. And this would include all bus stop locations, all real-time vehicle locations, just everything just dumped out in a format. So this particular format isn't directly suitable for mobile devices to consume. Typically, it's just a lot of information, and you don't want to access this type of information directly with a mobile device. But this type of information is useful if you're creating a website, for example, where you want to show all the locations of the bus, real-time locations of the buses to transit riders. In this case, you would want a fire hose access to display that via a website. Mobile devices have other constraints, which we'll talk about a little later, which we want to really provide a really efficient feed to the mobile device directly, and that can be done by third-party developers. So, and then within the fire hose, we have, again, the static information, which is fixed schedules, routes, and stops, and then the real-time information, which can change very quickly, and that includes estimated arrivals, vehicle positions, or service alerts. The second magnitude of open data is a faucet. So this is a very scaled down and precise subset of transit data. This is very suitable for mobile devices, and it typically answers the question for a transit rider or someone who wants to look at information that's directly relevant to their particular transit trip. So some examples of that for static information is stop ID 10 is served by Route 5. So if they're standing at stop ID 10, they know that which routes serve their particular stop. Under the real-time category, a sample type of faucet information would be, it is 2 minutes until Route 5 bus arrives at stop ID 10. So again, this is directly relevant to one particular location in the transit system and one rider's particular trip at that stop. And so these faucet, because these faucet formats are magnitude because they're very scaled down in terms of size, they're very accessible for mobile devices. And so typically this is, mobile devices will access a type of faucet interface. So now we're going to look at the data flow architecture within a transit information system. Most transit information systems will fit these general categories, and who owns these general categories can change, but you can typically divide a transit information system from end to end with these three categories here. So the three categories are producer, and then in the middle we have an aggregator or filter, and on the right-hand side we have a consumer. So on the very left, the producer role is typically the transit agency themselves. This includes the AVL information, which is produced typically by some type of positioning system, such as GPS on the bus itself. This information is then collected and sent to another location for permanent storage. In the middle here, we have an aggregator or a filter, and so this is typically a server-side system which takes all the information and the complete state of the transit system and then is able to chop that up and serve it out in smaller pieces to the consumer tier based on what the consumer tier wants. And again, we see how the different open data magnitudes fit in here. So the producer will generally provide this fire hose of information. This is the entire state of the transit system to the aggregator or the filterer, and then that information is then filtered down to a more precise subset of information. For example, the next bus to arrive at stop ID 10 will arrive in 5 minutes. And then that information is typically what is shown to the consumer, which can be a mobile device or a website. Usually that consumer tier is then what's accessed by the transit riders themselves. So we're going to dive a little deeper now into the producer and the aggregator and the relationship there and the open data fire hose magnitude and the different formats that are used to communicate this fire hose of information. So breaking this again down into static real-time or static information, which is the top here, and then the real-time information, which is on the bottom in these red balloons here. The General Transit Feed Specification, or GTFS, has really been a format which has become a de facto standard, meaning that you're really likely to encounter this particular format if you're looking at a transit agency's data, and we'll talk a little bit more about that in the next section. So GTFS really dominates the format for static scheduled transit information. So most developers expect that format to be available when you're talking about static transit data and a fire hose format of the entire transit system. Real-time, two of the common formats that are expected by developers and commonly used by developers include GTFS-real-time, which is a counterpart to the static GTFS format, as well as the Service Information for Real-Time Information, or SIRI. These two real-time formats have been used in a number of transit agencies and have really become fairly dominant in the transit developer community. There's a lot of tools for developers to work with these particular standards. You'll notice here that we do have the Transit Communications Interface Profiles, or TCIP, here on the left. However, TCIP was really designed more for open architectures that we talked about earlier. So open architectures are typically implemented within the producer's information system. So within the transit agency's information system, for example, to send information between the buses and the AVL server. So we include the TCIP more in this producer tier, and it's typically not a fire hose format that would be accessed by developers in between the layer of the producer and the aggregator or filter. And we have a few links down here at the bottom if you want to learn more about these particular formats. You can look these up in the handouts, and there's more documentation on these. So next we're going to look at the second two parts of the tier and their interface between those. So this is the aggregator, filter, and the consumer. And the open data between these two is the magnitude of the faucet. So this is the the scaled down information that's relevant for just a few different stops or routes. So common faucet formats are still emerging. They're not quite as well defined as GTFS is on the fire hose side. In the realm of static information for faucet formats, we have a lot of vendor or agency specific formats. These are a lot of the early adopters that wanted to share static information and real-time information as well, as you can see in the red balloon here. These are early adopters that wanted to share information, but there was really no widely accepted format to do that at the time. So these are either formats that the agency came up with in-house to share their data, or that a vendor implemented as part of a product. Another option that we have here is the One Bus Away APIs. I mentioned One Bus Away earlier is an open source project for real-time public transportation information. The One Bus Away API is available at a few different cities currently that have implemented the open source One Bus Away system, included the Puget Sound area in Washington. A version of this is available with MTA's BusTime system, and then in Tampa here with HART, with a pilot project we're doing with One Bus Away. And Atlanta, Georgia Tech is working with MARTA, and a One Bus Away API will be available soon. So One Bus Away, because it's open source, is easily deployable to different locations, and is definitely something to watch as an accepted or common static format that is emerging. And on the real-time side, we again have the vendor and agency-specific formats, as well as the One Bus Away API, which does real-time information. And then another unique contender here is a version of SIRI that was adopted that's a little more mobile device friendly, and we'll talk about why it's more mobile device friendly in a few slides here. But MTA pursued this as they wanted a way to use a validated standard to share information with real-time, or to share information with real-time information with mobile transit application developers. And the normal SIRI standard really wasn't designed to do that. So they modified it somewhat to make it more mobile device friendly. So this is another emerging format that we will likely see more of in the future. And again, we have some links down in the lower right-hand corner if you want to look up more information on these formats. So we're going to do a few different examples now just to show how different real-world applications fit into these particular architectures. So for an example, BART, Bay Area Rapid Transit, they are the producer tier here on the left, and they share two different types of the fire hose information. And they share both static information in the GTFS format and then real-time information in the GTFS-real-time format. And this information is then shared with Google, and then Google makes that information available to their you can access it via a website or also the Google Mobile Transit application for mobile devices. So this is an example of BART sharing the information, and then both the aggregator tier and the mobile device tier, the consumer tier, are both implemented by a completely separate entity, in this case the vendor is Google. But it's also important to note that because BART does share their GTFS and GTFS data, real-time data, openly to the public, really any third party could come in and replicate the exact same service that Google is providing. And so for example, Bing has, within the last year or so, has started providing transit service with using GTFS data from many of these transit agencies similar to BART. So this is why open data is important. It allows many different vendors to come in and use the exact same data formats and provide a service that can be customized based on the particular interest of that entity that's consuming the data, and then presented to transit riders. So another example is a project we're working on with HART here in Tampa, Florida. I mentioned the One Bus Away open source software system earlier. So in this particular case, HART has an installed AVL system, And we worked with HART to produce a GTFS real-time feed to complement the existing GTFS feed that HART was providing. So we are actually playing a role of the producer along with HART in this particular architecture. And then as part of our research project here at USF, we set up a one bus away software system on our USF servers. So we are playing the role of the aggregator here in the middleman. And then we are providing access to both static and real-time faucet formats that are more compatible with mobile devices via the one bus away APIs. And then we have the one bus away mobile apps, iPhone, Windows Phone, and Android here that make up the third-party mobile applications here. And so this is very similar to the same tiered architecture that's being used in Puget Sound and MTA, which we will actually see, I believe, on the next slide here, has a similar architecture. So MTA is also using one bus away, but they are actually running it in-house. So MTA is providing the role of the producer. They have their vehicles and tracking location information that comes from the vehicles. And then they are playing the role of the aggregator using the one bus away open source software system internally. So MTA is running the aggregation tier here as well. And then they are sharing static faucet data that's very precisely tailored for mobile devices via the one bus away API. And they are sharing real-time information via the SIRI REST API for mobile devices. And then they have made that data available so that external third-party developers could develop apps for particular platforms such as iPhone and Android. So successful open data formats, from what we've seen from existing industry examples, there's really three very important characteristics. The first is organic. So the open data format should be organic, and that means created and improved by the people actually producing and consuming the data. At the end of the day, you can produce a theoretical standard, but unless you actually run it, try to implement it and execute it in a programmatic environment, you're not really going to hit the issues that would present an actual producer from generating the data or an actual consumer from consuming that data. So it's really important to have the people that are really on the ground working with this data day to day to be the ones that are driving the standard. The second characteristic is openness. So there should be an open process for evolution to a particular format. And this, again, is driven by the first characteristic, that the open process should be driven by the people that are actually producing and consuming the data. And openness also applies to the data and documentation. So this should be something that should be just generally available on the web that a developer can easily access, examine, download information, sample data sets, download the documentation or read it openly on a website, so they don't have to go through a request process to access that documentation or sample data. Then finally, the successful open data formats should be easy to use for application developers. Really the purpose of open data is to make the data open so that application developers can create applications. And if it's not easy for application developers to do that, they're not going to create those applications. So the first thing is the documentation simple to understand. Ideally, you want a really, really small and compact data format, which yields a very small and compact documentation. It's very easy to understand and to know how data should fit into that format. Secondly, are there any existing open source software tools? So app developers typically look for open source tools to work with data sets because it's a quick way to jumpstart work on an application. If you already have software to look at to see how someone would typically consume and produce the data, it's much easier for an application developer to create their own app that consumes that same type of data. And then finally is the data provided via best practice for web service design. And so here we should be using things like a RESTful API design with JSON data encoding instead of using something like SOAP with XML. And I'll talk about what those two things are in a few slides here. So GTFS, as I mentioned before, is a really good example of a format that has become a de facto standard in terms of representing static schedule transit information. So we see a sample GTFS data set on the left here. It's a simple comma delimited format in plain text files that is then zipped up into a single zip file, which contains information about bus stops and then routes and other information about the schedules. And so this GTFS format was originally used to power Google Transit, but has gone on to power a lot of different types of applications. So currently there's over 500 agencies worldwide that have their data in GTFS format, and that includes 49 of the top 50 largest U.S. transit agencies by passenger mile who openly and publicly share their data, and also over 227 agencies worldwide that have chosen to publicly share their GTFS information. That includes, if we're looking at North America, it includes at least 20 Canadian transit agencies as well. And again, while many agencies created GTFS for access to the free Google Transit Trip Planner, GTFS has been used by a wide variety of different applications, including One Bus Away, which uses GTFS, Open Trip Planner, and a number of other web and mobile applications. If you're interested in seeing what agencies are openly sharing their data, today the closest thing we have to a centralized list is the GTFS data exchange, and we have the web URL here. Or you can always just ask your local agency too if they're sharing their data in GTFS format. So I'm going to cover some things on what an agency should do to be considered developer friendly, and this is the best way to promote app development based on your open data. So the first thing you want to do is look at your relationship with application developers as a relationship. It's something that does require maintenance. It's something that requires communication. So it's not something that you should just throw your data up on the web and then forget about it. Developers may find it, they may not find it. You're much more likely to get a lot more attention if you actively work to make sure application developers know about the data and you're able to answer questions or address any problems that they find. So the first thing that we recommend is to openly share your GTFS data on GTFS Data Exchange. And again, don't password protect it or put it behind a login, because that just makes it really difficult for application developers to maintain their applications with the newest data. And we suggest share your real-time data too if you're able to. Real-time data is still emerging for a lot of agencies, and there really isn't a good national list at this point for agencies sharing real-time, but it's something that some people are working on. Then we also suggest creating a developer page. And so this is an example that you see here on the right is HART's developer page in Tampa, Florida, that describes all the different data sets that are available for developers to work with. And typically this will include things like a terms of service, which we'll talk about in a couple of seconds here, or you can call that a license as well. We also suggest you create developer mailing lists, which can be a group where announcements are usually distributed, so announcing that a new updated data set's available. It's also a forum where you can have questions and answers or collaboration. So developers can ask questions about the data sets. The agency can answer those questions, or other developers can answer those questions. This also promotes collaboration where developers in the local area can connect with one another, share common experiences, and help each other troubleshoot problems. And this really helps reduce the burden on the agency for answering every single question that comes up. And we also suggest that you announce your resources on the Transit Developers Group. And this is a Google group. It is a format, so it's basically a mailing list, and it's a very popular location where many transit agencies, or where many application developers monitor the progress of the state of open transit data. And in terms of being developer friendly, we also suggest you use a very simple terms of service and base it on other existing industry examples. And we have some examples cited here at the bottom for 5 different example terms of use that are being used at these particular agencies. And the more common that you can make your terms of service to existing terms of service, the fewer lawyers are involved in terms of trying to figure out what you're actually allowed to do with the data, and that really cuts down on the overhead of somebody just really getting to the end goal, which is creating an application based on the data. We also suggest using GTFS naming conventions for data fields throughout your data sets. This is something that, since GTFS has become such a dominant format for the static scheduled transit data, it really makes sense to make sure that if you're providing any other sets of transit data, make sure that the names of the fields for data that mean the same thing are the exact same name. So, and that includes the values of the fields as well. So one example that we've seen in the past is there's a direction ID which defines whether a route is inbound or outbound for the GTFS data, and that's defined as either a 0 or a 1. But then if you define direction as north, south, east, or west in another data set, and there's really no clear mapping between the 0s and 1s, the north, south, east, west, it makes it really difficult for developers to figure out how to match your different data sets together to make sure that when you're talking about Route 5 East, which direction are you talking about? Is it a 0 or a 1, or is it north, south, east, west? So we suggest matching, or at least making available the same fields with the same data types to make sure you can match it up with your GTFS data. And on a similar note, you also want to make sure that your IDs, your unique identifiers for individual records, match among data sets. So if you have a bus stop ID, or a better example is probably a trip ID, that's say trip ID 100, which defines a particular visitation of stops on a route, and you have that in your real-time data, it should definitely match that same trip ID that defines that same trip should be the exact same integer value as the ID that's in your static GTFS data. And on one final note on being developer friendly here, you want to use the developer or mobile friendly data formats. And so for data, these involves the formats that we talked about earlier in the concept of the transit data architecture. So GTFS for static data, GTFS-real-time, and then the SIRI REST API, which MTA has used in their BusTime API. And for general mobile API design, this is really not transit specific, but for any type of API where you're providing information to a mobile app, you really want to use a RESTful web service design and JSON data encoding. You do not want to use SOAP and XML. And while you really don't even need to understand exactly what these terms are, you just need to understand why they're different. So when a mobile application is making a request to a server, on the left here we have how much data is required to do that using the SOAP format. And using an HTTP post requires about 3.7 times less information. And this has a direct impact on things like device battery life and the amount of data that's chewed out of a consumer's data plan. And similarly, if you format your responses using XML, this is the exact same response versus formatted in JSON. So it's 1.8 times larger using XML versus JSON for the exact same data or the exact same information, just formatted differently. And so just to show that these differences do actually make a difference, these are some tests that we conducted. So this is SOAP versus HTTP, or a RESTful type of RESTful web service. So we're talking differences of hours of battery life. For example, if you're making a request every 4 seconds to a server, you get about 2 hours longer of battery life using a RESTful web service design versus a SOAP design to query the web service. And that trend continues no matter how often you're querying the web service. So again, you want to use a RESTful web service design using HTTP directly. You want to really stay away from SOAP and XML. And then for the response and how it's formatted, again, our choices are XML or JSON. And as we saw in the previous slides, JSON is much more compact than XML. And this translates into a significant amount of time for a mobile phone to fully process a response from, for example, checking how long it's going to be until a bus arrives at a bus stop. So when you first power up your app, the longest amount of time is going to be to parse that first set of information that's returned from the server. And if you're using XML for that format, as we see here, that takes about 17 seconds on a Samsung Galaxy S3 device. So this is a top-tier device that is about as capable as a smartphone you're going to get, at least until the next generation comes out very shortly. But this is, a very capable device. And versus if you encode that same information in JSON, which is much more compact, you're looking at about 4 seconds to parse that information. And this is directly relevant to the transit rider because they're going to be sitting there waiting for the information to be processed. And so they're going to be sitting there waiting for 4 seconds. If the transit agency provides the their data in the JSON format, and they're going to be standing there for about 17 seconds if you use XML. And XML is just in generally not very mobile device friendly, and there aren't even a lot of tools to work with the XML format on mobile devices. So the lesson here is to use JSON, do not use XML. And then one final tip is to get the word out. So after application developers have created apps that work well, they use your data, you want to make sure that the writers know about them. So one thing that's been used in the transit industry is the concept of an app center, and we see BART's app center here, where they're showcasing the different applications that are available for their transit system on different mobile device platforms. And we have some URLs here if you want to check out how these app centers look at these different agencies. And if you follow all these practices, what we've seen in the industry is that these practices typically lead to great apps. And there's just a small number of sample apps here that we put on the screen just to show the different applications. And these 3 of the 5 here are for mobile, and then Magnificent is a interesting way to see how far you can get using public transportation in a certain amount of time. And while the best practices for creating and maintaining GTFS data are somewhat beyond the scope of this particular presentation, we've included some resources here that focus more on that if you want to get more information about that on that particular topic. So our conclusions for the webinar today are open data, and especially GTFS, makes transit apps possible. And you really want to understand the difference between open data, open architectures, and open source software when you're talking with developers. And they're really going to be most concerned about open data. And that means that a transit agency is openly sharing their both static and real-time information, if available, with transit developers in the general public. You also want to understand the differences in data formats, static, which changes very infrequently, and real-time, which changes very, very frequently, and fire hose, which is a dump of the entire state of the transit system, versus faucet, which is a very precise subset, such as the next bus on this particular bus stop will arrive in 5 minutes. You also want to understand that certain formats are more appropriate than others for certain situations. So, for example, if you want mobile apps to be developed for your transit system, you really want to make your data available in data formats that are mobile application friendly. And again, RESTful web services and the JSON data format. And then finally, being developer friendly encourages mobile app development, which is really what open data is all about. So we hope that you have good experiences, you follow these recommendations, and they end up with a lot of mobile apps. So that concludes our presentation today, and I'd be happy to take any questions.
Okay, thank you, Sean, and thank you, Jennifer, for opening up that. If you would, we have a couple questions ready in the queue, and if you click on the Q&A above, you can type in your question and click Ask. You can submit one question at a time, and we will go through that list. And our first question, Sean, is, would the data be on a protected server with limited edit permissions? Would CUTR or the presenter be interested in providing a workshop for formulating data sets?
So I think if I understand the question directly, it's how do you create a GTFS data set? So that is something. There are some tools out there to create and maintain GTFS data sets, and it's something we can definitely look at for a future webinar topic. I encourage, if there's a lot of interest in that, definitely contact us. In the handout itself on one of the slides on I think it's slide 32, we do have a number of links that talk about that more specifically and cite particular tools that are used to create GTFS data. But if you'd like more specific recommendations, please just contact me, and I'll be happy to provide you more information.
Okay, thank you. The next is GTFS real-time proven to be efficient in terms of response and update speed?
I would say yes at this point. In Tampa here, we are updating our GTFS real-time feed every, I believe it's every 5 seconds currently. So that's independent of how often the information is updated by HART internally. But it's a very compact, it's a binary data format. So for example, we're providing in the GTFS real-time feed both trip updates, which are the estimated vehicle arrival times, and the vehicle positions, so the X and Y, the latitude and longitude for each individual vehicle. So that amounts to about 17 kilobytes total for that entire set of information of the entire transit system. So updating, retrieving 17 kilobytes of information in between servers is pretty small. So we have not seen any issues updating that every 5 seconds.
Okay. Sean, has there been any particular, say, reluctance of transit agencies to share this data? I know you said, I think, 49 out of 50 are the largest stars, but I don't know about, say, the moderately sized transit agencies. I mean, yeah. Are there opportunities, for example, and let me have kind of a follow-up, are there opportunities for monetizing this from a transit agency perspective?
So to answer the first question, really agencies of all different sizes can share their data. There's a wide range of agencies from very small to very large that are sharing data. So I don't think agency size doesn't necessarily dictate whether or not you can share data. And for smaller agencies that don't have the resources in-house to really create and maintain that data, there's a number of vendors out there and tools that can be used. And so I think in one of the references that we cite, one vendor in particular is able to create a GTFS data set for about $200 to $500 per route based on the complexity of the route and the size of the system. So it does seem very affordable way to do that. In terms of monetizing data, early on in the process of agencies sharing data, there were some agencies that tried to charge developers for access to the information and for a fee. That approach really didn't pan out and wasn't very successful. I think most agencies have realized that the potential cost savings to them in terms of not having to implement their own mobile app for iPhone, mobile app for Android, mobile app for Windows Phone, and all these other dissemination channels, that savings far outweighs any potential revenue that would be created by selling their data. So really, it's from a cost-benefit perspective, it's more beneficial for them to share their information openly and then benefit from all the different types of applications that are created based on that data.
All right, kind of a follow-up then to that, Sean. If, from a perspective of what a transit agency might expect from having these real-time apps, for example, available to their customers, is there any experience of seeing increases in ridership as a result of this, or increases in customer satisfaction?
That's a really good question, and that's something that that a lot of researchers have been trying to capture recently, because there's a lot of anecdotal evidence that if provided information, riders are much more happy with the system, and there actually have been studies saying that their riders' perception of on-time performance increases when they have access to real-time information versus when they do not have access to real-time information. And there was a recent study, I believe it was CTA, that showed that riders with access to real-time did have a better experience as well, so through mobile apps. So if anyone's interested in the precise references for that, we can definitely pull those together. The answer is yes, although as researchers we're still working on better quantifying that through experiments, and that's actually part of the research project that we're doing right now with One Bus Away in Tampa, is to try to capture that. Hopefully we have a control group of 200 people that don't have access to real time and 200 that do, and we hope that at the end of the project, the people that do have access to real time will have, as you mentioned, better perceptions of public transportation.
Okay. Kind of on the issue you brought up regarding smartphones, are there ways of delivering this via text messages for those that don't have smartphones?
Yes, absolutely, and there's a number of agencies that have implemented that, including Puget Sound and Detroit via an open data concept. So the raw data is made available to a third-party developer, and then a third-party developer decides how to best integrate that with existing SMS providers and services. So text messaging is one way to do that. There's also ways to provide text-only mobile websites that are available on lower-end devices and that aren't smartphones. So there's definitely ways to make it the data information available. And even beyond smartphones, there's also instances in Seattle where coffee shops have just thrown up a big screen television and connected the output of the One Bus Away system to their TV, so that just people in the coffee shop without potentially any phone could benefit from the real-time information that was derived from the open data.
That's pretty creative. You talked a little bit about the GTFS format and converting a couple $100 per route, I believe you said. But any thought about how much maintenance time, from a transit agency to keep the data current, and that it's not just open up the door and walk away from it? Any idea
Sure.
how much is involved?
Yeah, well, first I'll say that that's definitely something to consider. When you're considering open data, you want to understand that it's not just creating the data set, maintaining it is crucial. Otherwise, the data set, as soon as there's the first markup change and route stops or schedules change, that data instantly becomes old, and you have to work on improving it. So there are tools that such as Trapeze and Hastis, where if the agency is already using those scheduling tools, those tools do provide a feature to export that same information to GTFS. Probably the best approach is to talk to other agencies and some of your peers that are providing GTFS data and just ask them. Our perception has been from the agencies we've talked to is that it's maybe a couple hours of work, a few hours of work, depending on, again, the size of the agency and the way that they're producing the data to maintain that information.
Okay. Are you seeing that these apps have been transferable, like develop it in Portland and can be used in Cleveland?
That's an excellent question. We've seen some of that on the static trip planning perspective. For example, Google Maps, Google Transit on a mobile application, you can go to any of those 200 plus agencies in the U.S. that are on Google Transit sharing data in GTFS and plan a trip from point A to point B. And it'll tell you which routes to get on and what stops to get off. Real-time is a little trickier because of the lack of consistency of APIs. The number of apps that are transferable between more than one city for real-time information is much, much smaller. But we hope with some of the convergence we're seeing on some of the real-time formats and different interesting open source systems like One Bus Away, hopefully some of those walls will start coming down really soon.
Okay. Well, thank you, Sean. Before we close today, I failed to mention earlier that we have applied for certification maintenance credits from the American Planning Association for any of you that are currently AICP certified. We would expect to get that hopefully get that approved, and we'll let you know. To do that, though, we would ask that if everybody take a minute or so to complete the evaluation, especially if those wanting certification maintenance credits, just provide your contact info at the end of this evaluation, and we'll let you know when they're approved and what steps you need to get credit. So with that, on behalf of the Center for Urban Transportation Research at the University of South Florida, thank you for joining us today. Thank you, Sean. Thank you, Jennifer. And we'll hope to see you in another couple weeks. Good day.